Hello everyone, welcome you all. I hope everyone is well in this COVID-19 time. So in this video, I will solve some four problems related to solid state magnetism and nuclear chemistry. Okay, let's start one by one. So this is question number 28. So this is like this. The value of D11 in a cubic crystal is 325.6 picometer. What is the value of 3D333? Uh, is They have given four options. Okay. So now the question is basically they're asking the distance between the Miller plane. So in a crystal, you have several planes, and each plane will be defined by some numbers. HKL. So each plane will be defined by these three numbers HKL. And if you have a parallel planes, so there may be parallel planes, and the distance between the parallel planes you can get with the help of this formula. This is exclusively for cubic crystal. For other crystal lattice, the formula will be different. Okay, for cubic crystal, so you have this formula DHKL is equal to a by root over h square k square plus l square. Okay, they have given for D111 326.6 picometer. Okay, now if you put 111 for HKL, what do you get? D111 equal to a by root over 3. Okay, just keep it. We'll use this part in the later stage. Now in the question, we need to determine the 33 type. So if you write HKL equal to 333 and put in the formula, you get a by root over 27. Now what is a 27? 27 is nothing but 3 root over 3. So 3 square root 3. Now what you can do, you can do slight adjustment and you can write 1 a by root over 3 is equal to D111. Okay, so 1 by 3 into D11. So finally D111 is given 325.6, which is finally if you put, you'll get 108.5. The answer is this. Okay, uh, this is the answer for the question number 28C. Now let us move on to question number 49. So 49 is about the magnetism. Very interesting problem. So the question is like this: the actual magnetic moment of a large shows a large deviation from spin only. In which case, so they have given four options. So usually in the case of transition metal, the magnetic moment is very close to the spin only value, except for few cases, but in most of the cases for transition metal the magnetic moment is equal to spin only value. Okay, that is the extra from now here I have given a table. In the table, so you have different metal: titanium, vanadium, gadolinium and samarium, all are in class 3 oxidation state. So the number of electron for titanium 3 plus is 2, vanadium is titanium is 1, vanadium is 2, and gadolinium 7 and samarium 5. Now if you use the formula I have given, mu effective equal to root over n into n plus 2 in the unit of Bohr magneton. So you get values, you can calculate it. Now if you see in the last column I have given the actual experimental value. For titanium the value is exact. For vanadium is also not much deviation. For gadolinium also there is not much deviation. But for samarium the change is very large. So that means I cannot use the spin only formula in order to explain the magnetic properties of samarium 3 plus. Okay, so this is the answer for the question 49. The samarium 3 plus shows the largest deviation from the spin only value. Okay, there is another question which is similar to your earlier question. although this came in different year. So this is asking the spin only magnetic moment and the spectroscopic ground state term symbol of manganese center in MnF6 3 minus ion respectively. So they have given four option. Now the important thing to note here is that the manganese is a D4 ion. D4 ion can be high spin, D4 ion can be low spin. So you need to see that the fluoride is basically considered as a weak field ligand. So it should, the manganese complex should be high spin compound. Okay. Now if it is high spin, what will be the number of unpaired electron? So it is a 4 unpaired electron. So for 4 unpaired electron, you use the same formula as earlier I've shown, and you end up with 4.9 Bohr magneton. And the term symbol you get for this is 5D. Okay, so if you guys want to know about more about term symbol, I have made two different videos on term symbol, how to derive the ground state term symbol. So you guys check for that. So there I have given a detailed way to find out the term symbol. Okay, let us move to another problem. So this problem is telling you, asking you have two alpha particles with a speed of s1 and s2 having a kinetic energy of 1 and 2 MeV. What is the relationship between these two velocities? Okay, first of all, what is alpha particle? Alpha particle is nothing but helium nucleus. So you take a helium atom, you remove the two electron, then you will get a helium particle. This is helium particle, so it's a positively charged particle. Now it is moving with some speed. There are two particles s1 and s2. Now what is the kinetic energy? Kinetic energy formula is half mv square. Now if I use the formula for both the particles, what I will get, for the first particle I will get half m s1 square equal to 1 MeV, and for the second particle I will get half m s2 square equal to 2 MeV. Okay, 2 MeV I can write as 2 into 1 MeV, and in case of 1 MeV I can just put this half ms1 square and then do you the mathematical cancellation 2 and 2. Finally you will be ending up with s equal to root over 2 s1. So this is the important thing to the important thing is to remember that you are using the same particle, so the mass will be constant, so there is no change in the mass. Okay, so the finally you get s equal to root over 2 and s1 is outside, so the answer is C. So I hope these questions will help you while preparing your competitive exam. So if you guys want to know more about some topics, please message me, share my videos, and also subscribe to get more information on topics. So I'll be happy to answer any questions about the topic if you guys want to know more. So in the future I'll come up with some new videos on some new problems. Thank you guys for listening the videos. Bye bye.